Okay. Yesterday, Fredo, introduction to oxidation state, right? Okay. So I hope you know the meaning of oxidation state and valency, right? And today the heading is what? Use of oxidation numbers to understand electron transfer between atoms in redox reaction, right? Okay, what's the meaning of redox reaction? You should know that there are 4 types of reaction, right? One is acid-base reaction, and second one, third one, precipitation reaction. Fourth one is complexation reaction. These are the four types of reaction, right? These are the 4 types of chemical reaction, right? Acid-base reaction, precipitation reaction, complexation reaction, and the second one is oxidation reduction reaction, right? You can combine the word oxidation and reduction. That means reduction and oxidation as redox reaction, right? Redox reaction, acid-base reaction, precipitation reaction, redox reaction, complexation reaction. Okay, now we are going to be interested in redox reaction. Okay, what's the meaning of redox reaction? Redox reaction is any reaction that involves in the change in oxidation state, right? Change in oxidation state. That means some atoms get oxidized and some get reduced, right? Okay, that means what? Redox, we have already studied, right? Meaning of reduction and meaning of oxidation. We know that, right? What's oxidation? Oxidation means loss of electron, and the reduction means gain of electron. Once again, oxidation means loss of electron, and you can easily keep it in mind that oxidation is the increase in the oxidation number, right? Increase in the oxidation number is called oxidation. Reduction means decrease in the oxidation state. It's very easy, right? It's very easy to remember. But if you are asked to write the definition for oxidation and reduction, you should write like just as I said earlier, just before, right? What oxidation is the loss of electron, and the reduction is the gain of electron, right? Okay. Got it? Yes. And now just take a simple example. Sodium plus chlorine react together to form sodium chloride. What's the oxidation state of sodium initially? What? Oxidation state of sodium? 0. Initially 0. Chlorine, oxidation state of Cl2. What? 0. Why? They are elements. Better? Elements. Oxidation states of elements are normally, not normally, always 0. So what about the sodium chloride? What's the oxidation state of sodium? You know, plus 1. Chlorine minus 1. Right? This is called full reaction. And you can separate this full reaction into 2 half reactions. Right? What are those 2 half reactions? Sodium 0 to plus 1. That means increasing the oxidation state 0 to plus 1. There is an increase in the oxidation state during the reaction. So sodium get oxidized, and chlorine 0 to minus 1 get reduced. Chlorine get reduced, right? Okay. So in the this is the oxidation, and the reduction is Cl minus. Right? These two are called half reaction. If you combine these two, or if you add these two, you will end up with this. Right? We'll balance that. Right? Okay. If you add these two reactions, this would be the result. Right? Okay. Now, these two are called a half reaction, and the first half reaction is called oxidation half reaction, and this one is called reduction half reaction. Oxidation half reaction, reduction half reaction. Right? Okay. Now, what's the main difference between half reactions and full reaction? What's the main difference between half reactions and full reaction? What's the difference? You can easily say, what's the reaction? Just look at the reactions. What's the difference? In half reaction, electrons involved, right? Electrons, right? But here, can you see electron? No, electrons are not here, right? So here, electrons will not appear, but here, in half reaction, electrons should appear, right? Okay, so this is half reaction. Chlorine plus 2 electron, and you can add sodium minus electron Na plus. But normally we don't put minus, right? We don't put minus in chemical reaction. Minus electron means you should add that minus in minus 2 electron. If minus 2 electron, what you should do? Arrow is like equal mark, equal sign, right? So you should bring that minus 2 electron here, so plus 2 electron, right? This is the way you have to write the half reaction. Don't add minus signs, right? Always you should add plus signs, right? Always positive plus sign is compulsory. Do not write negative signs, right? Okay, so this is oxidation half reaction, and this one is reduction half reaction. Okay, so during this is an example of redox reaction. During redox reaction, you should remember that one element loses electrons, and such electron is gained by other element, right? One loses and other gains that electron. Got it? So this type of reaction is called redox reaction. Redox reaction. Okay. Okay. I have given some more examples. First example. Next page. You can see one example, right? Combustion of methane. Right? Methane. Combustion. What's the meaning of combustion? Combustion. Burning. Right? Combustion means burning in oxygen. Right? Okay. So, combustion of methane. Right? I'll write the reaction. CH4 plus O2. The products are CO2 plus water. Right? That's the product. CO2. It's been given, right? Okay, let's balance the reaction. Right? 1, 2. Okay, I have balanced. Right? And let's check the oxidation state of each and every element. Right? First, oxidation state of carbon. Oxidation state of carbon is what? Here. In CH4, what's the oxidation state of carbon and what's the oxidation state of hydrogen? Minus 4, oxidation state of carbon, minus 4. Oxidation state of hydrogen, plus 1. Right? Plus 1. And Here, there is only oxygen. What's the oxidation state of that oxygen? What's the oxidation state? 0, right? 0 is element. Oxidation state is 0. And there, what's the oxidation state of carbon here? What's the oxidation state of carbon? Plus 4, right? Oxidation state of carbon is plus 4, right? And here, oxidation state of oxygen minus 2, right? Oxidation state of hydrogen plus 1. Oxidation state of oxygen minus 2. And you can clearly see that oxidation state of hydrogen is unchanged, right? Plus 1, plus 1. So hydrogen does not involve in or does not undergo oxidation or reduction, right? Hydrogen does not undergo oxidation or reduction. Sorry, right? And what about carbon? Here oxidation state of carbon is minus 4, but here oxidation state of carbon is plus 4. So oxidation number has increased. So carbon undergoes what? Oxidation. Oh, right? Okay. Okay, got it? So carbon underwent oxidation, minus 2 to plus 4. Right? How many electrons it loses? Right? How many electrons? How many electrons it lost during that oxidation? Minus 4 to plus 4. How many electrons? Oxidation means what? Oxidation number increases means oxidation. When the oxidation number increases, electrons will be lost or electrons will be gained. Electrons will be lost. You can easily remember that, right? Easily you can keep it in mind. How? Oxidation means oxidation number increase. Oxidation means increase in oxidation state. Increase in oxidation state means what? Oxidation state increase means electron should be removed, because electron is negative charge. If electron increase, number of electron increases, what will happen? Negative charge increases. That means minus should increase. Minus increases means oxidation state decreases. Right? So you can see oxidation number is defined by positive charge. Right? Positive charge. Oxidation number increases means oxidation. Oxidation number decreases means reduction. So carbon, oxidation state of carbon has been changed from minus 4 to plus 4. So carbon has lost 8 electrons. Minus 4 to plus 4. What's the difference? 8. Right? And oxygen 0 to minus 2. This is oxygen in elemental state, but in product oxygen exists inside CO2 and also inside water. Right? You can see oxygen inside CO2 and inside water. What's the oxidation state now? Minus 2. Initially 0, now minus 2. So oxidation number has decreased. So what you can say? Oxygen underwent what? Reduction. Right? So 8 electron has been lost from carbon, and such electrons have been gained by oxygen. So oxygen gained how many electrons? Totally oxygen gained O2, O2, O2. This O2 gained 8 electrons. Right? 8, because carbon lost 8 electrons. So that total electron should be gained by oxygen, because hydrogen, no role of hydrogen here. Hydrogen has no role here. Okay? Right? And what's the oxidation? And which one is the oxidizing agent and which one is the reducing agent? CH4 is the CH4 is the reducing agent. O2 is the oxidizing agent. Where you have learned those things in unit 1. Anything that undergoes reduction is oxidizing agent. Anything undergoes oxidation is reducing agent. Okay, you should remember that, right? We have studied it completely, right? Okay, so I don't need to repeat it again, right? Okay. Okay. And there's another example: combustion of propane. Combustion of propane. CH3, CH2, CH3. Alright.